we don't really spend a lot of time in geometry in this class. Um, if you took if you took math at CVC before the last summer, we had a lot more geometry, and then we just decided that geometry is just not that important for most people. So we're not going to do a lot, but you will see some geometry applications like in your next classes, or if you do go into the algebra series, you'll do a little bit more geometry as well. But most of you guys, I'm guessing, are probably going to take Math 50. Which does not have a lot of geometry in it. So a couple of things, just some basics about like angles, okay, right? So the idea is that, if you have two lines or like say two rays or something, so say like two rays, then wherever they meet, right, the angle is just how big the distance is from the two like rays to each other, right? So I'm guessing everyone here knows what an angle is. Okay. It's just a measure of how far apart things are. And if you have a full, so if you're looking at angles, if you have a perfect square angle, right, then what is this? Yeah, so this is a 90-degree angle, and sometimes it's called a right angle. And if you're looking at a problem, like a geometry problem, right angles or 90-degree angles are always marked with a square. So you see the square in the corner, that tells you that that's a 90-degree angle. If you have, if you have a big enough angle to form a straight line, essentially, that's 180 degrees. Not percent, degrees. So we measure angles in degrees, and the way it works is, right, so that a full circle is 360 degrees, right? So a full rotation around is 360 degrees, half a rotation is 180 degrees, and a quarter rotation makes it a right angle. Yeah? I'm guessing that seems vaguely familiar. Is my guess. There's some properties of special types of angles. So if you have, for example, you can have complementary angles. Okay. So complementary angles, these are angles that add to 90 degrees. So in other words, it's like if you put together one angle and you put together another angle, then together they would make that 45 degrees. So those are considered complementary if they add up to 90. And then we also have supplementary angles. And so those are the ones that add up to 180. So like, you can have one angle, and then you could have another angle, and together they make that straight line, so then that would be a supplementary. Yeah? Does that sound vaguely familiar? Okay, so you can solve, for whatever the angle has to be. So like, for example, if I had, consider an angle, I don't know, like, well, I shouldn't say 90, that's a bad plan. That's like, say, 62 degrees, right? And maybe I want you to find, well, how would you find the complementary angle? Yeah, you just figure out what has to add up to 90 degrees, so you subtract them, so that would have to be, what, 28? Okay, and then you can figure out the supplementary angle really easily because you just subtract it from 180. And then that's just, what, 118? Okay.
What is that word?
What?
After example.
Oh, just it doesn't say anything because it's gibberish. It was supposed to be considered, but I just skipped a whole bunch of letters in the word. Yeah, it's good as if my gibberish at least has the right number of letters in the words. That helps. That's supposed to say consider 62 degrees. Yeah, I kind of just hope that you guys can just like pick it up from context a lot of times because sometimes it's not the best. But all right, so these are the basics of angles. where you'll find angles pop up most often when you're doing work with like triangle geometry. And so some properties of triangles. Are you guys good with this? Yeah? Yeah. Okay. So a triangle, right, that's just like a polygon that has, what, 3 angles in it. It's literally like 3, that's why it's called a triangle, because it has 3 angles in it. And then what's true about the angles in a triangle? Anybody know? Yeah, so all the angles in a triangle have to add up to 180. So if you have, so if you're labeling triangles, they're usually labeled by the points that connect the triangle, and the points are usually given like capital letters. Okay, so this would be, so what you have here is you could have a point B, you know, then, well, or A, B, and C, and they're all capital. Then you can also have the angle that's inside the triangles, and they use this notation where it's like it's almost like an inequality, but it's not. Okay, so like this right here would be angle B, because it's the angle that's attached to point B. So that's just like shows an angle next to the letter, and then it just tells you where the triangle you're talking about. And then if you're talking about side lengths, usually the side lengths are using lowercase letters. And the side length is actually the side across from the angle with that letter. So side A would actually be across the triangle from angle A. Side B would open up to side B. Side C would open, or angle C opens up to side C. So it's kind of like the side is defined by whatever angle it's pointing to.
How do you know which one is A and B is?
Oh, it'll be labeled on the. It'll be labeled on the side there. I'll give you a couple that are labeled. Okay. Yeah, side length. A, B, and C. It's just because it doesn't make sense to name it, but you can't name it by the point the line is attached to, because 2 lines are attached to point A. So instead we named it this something that's across. All right, and then what's true, what has to be true about triangles is that if you add up all of the angles in a triangle, they have to equal 180 degrees. All right. So this is just generally how triangles are labeled. It's good to know that the angles have to add up to 180. If you have 2 angles in a triangle, you can always solve for the third one, right? Just figure out what it has to be to make the angles add up to 180 degrees. We've focused specifically on a couple types of triangles. So if you see like similar triangles, or really any polygons that are similar, what that means is these are triangles which are like expansions or contractions of each other, or like scales. Contractions of each other. So it's like one's just like a, yeah, it looks bad, but it's contractions. But the idea is like they're just scaled up. They're blow ups. Or so like, you know, you could have a triangle, say a triangle where this is like 1.5 to 2 or something like that. And then if you were to like scale that up, say like basically double the entire triangle, this would be like 3, 4, and 4. You know, so you can scale your triangles up and down. But what happens is that in similar triangles, the side lengths are bigger, so the triangle itself gets bigger, but the angles don't change. So you don't actually change the basic shape, you just change the size. Those are called similar triangles. Now, that actually can allow you to solve, if you know two triangles are similar, so let's say that you have similar triangles. Let's say that you have one triangle here, and maybe this one over here is just a little bit bigger than it. And let's say that maybe this side length was 0.8, and this side length right here was 1.4, and maybe this side length right here is 1, and this side length right here is unknown. Now the question is there a way that you could solve for the unknown length of that bigger triangle? There is, right? Because since they're similar, it's like the angles hold between the triangles, but the proportions, like the scale of them, hold as well. So what kind of equation could you set up here? Yeah, this is like a proportional or ratio equation. It says like you could make the comparison and say, okay, well, like which two sides can you compare to each other?
1.4 to x is 1.8 to 1.
Yeah, so you could say, okay, well, 1.4 is the side on the little triangle that matches with x on the big triangle. Okay, so you like set up this thing where it's like, you know, little to big. Well, that's also what's also true though is then that ratio should be the same as 0.8 on the little triangle to 1 on the big. Okay, so you like match sides and set up a ratio or proportional equation, and then you cross multiply. Okay, so remember we've seen these earlier in the course. So really what this becomes is the equation 1.4 times 1 equals 0.8x, but that's just 1.4 equals 0.8x. And then if you divide both sides by 0.8, what's the answer? 1.75. Okay. So. Questions on that one? You don't have to match it up that way. I mean, could you match it up another way? You can match it up like a bajillion ways because it's like what happens is, so I'll redraw these triangles for you. Was it 1.4 to 0.8? And then this one was like, what, 1 to x? You know, we said, yeah, you set it up 1.4 to x as 0.8 is to 1. That's one option. Another option is you could compare within triangles, like 1.4 is to 0.8, right? Like these two compare to each other. The same way that like x compares to 1. So you can, it doesn't, and you can flip them all too. So it's like, you could flip these two as long as you flip those two. So it's just, you just have to make sure they match. So it either can go like little to big, or it can go like within the triangle, like this side to this side. But either way, you end up solving the same equation. Questions on that one? Okay. So this is really just like, honestly, this is just like a hodgepodge of geometry topics that I'm just going to dump on you because we have to cover them. So hopefully you're not offended by that. But
Can you get a copy of the final?
of what?
Final.
Do you get a copy of it?
Yeah, can you get a copy now?
There is a practice final out.
I know, but like the final.
Yeah, I don't have it. I don't even write it.
Okay.
I couldn't even if I wanted to, I couldn't.
Sometimes you can say things with a straight enough face, they
Yeah.
just take it.
Even if I wanted to, I couldn't. All right, there's only one more thing I want to talk about, okay? So then on the topic of angles and specifically triangles, right triangles have a lot of really useful applications in math. So a right triangle is just a triangle that contains a 90-degree angle. Oops, 90-degree angle. Okay. So any triangle that has a 90-degree angle will be considered a right triangle. Now, there's a relationship between the sides of a right triangle, which is known as the Pythagorean theorem. Yes. And it says that if you take the two short lengths of the triangle and square them, they should add up to the hypotenuse squared. So these right here, these are sometimes called legs or sides of the triangle. The long side is always called the hypotenuse. Okay. So this is useful actually in a lot of applications. It turns out, I'm guessing most of probably some important point. It's like one of those formulas that you just like remember from high school, even if you don't actually remember what it was about, right? And so, but this is what it applies to. It applies to the side lengths of a right triangle. So you can, so like I could give you, an example where it's like maybe you have one side length and maybe this is, say like, trying to remember what my perfect squares are. I think like, actually let's go with 3 and 5 and x. So how could I solve for x? See, here's the way. Yeah, so remember, these are your sides. And so it doesn't matter if I give you two sides and the leg's missing or the hypotenuse is missing or if the hypotenuse is there, it doesn't matter. The point is that these are side lengths. So the format is a squared plus b squared equals c squared. So then one side is 3, one side is x, and the hypotenuse, right? The hypotenuse is always the long side, is 5. Okay. So here 3 squared would be 9, and 5 squared is, So how do you solve? So x squared equals 16. How do you get rid of a square? Yeah, so to undo the square, that's why we need square roots. So square roots are an important operation because when you come into equations that involve squares in them, the square root can undo that and help you solve the problem. And so then here, it's just 4. Okay. All right. Questions about that one?
Do we have a one where it goes b plus or minus?
No, that's something totally different.
That's what we were just talking about.
Yeah, that's a quadratic formula. It's to find the zeros of a quadratic.
Yeah.
Okay, we're not doing that one. So, but questions about this one? Now, sometimes it's nice because you'll end up with values that have perfect square roots, but that's not always the case. So you may have to approximate them, right? So you might have something where it's like, here's your right triangle, say here's 3, here's 6, and there's your unknown variable, right? So to solve this, you could set it up, frame it like a Pythagorean theorem problem. What happens here? Well, 3 squared is 9, 6 squared is 36, and then 9 plus 36 is 45. But what happens when you go to take the square root of 45? Well, this is why we had to cover square roots earlier in the quarter and talk about approximating them. You just plug it in your calculator, and it's just going to give you a decimal. So it's like 4 point, or no, it's not going to be 4. It's going to be 6 point something. 7, 0, ... You know. And so then you would just have to round it.
Have like a leftover of like a radical of 5 or something.
What about it?
How do you do that?
We don't do that.
At all? Like you don't ever have to?
No. Yeah, I know what you're talking about. You're saying that root 45, this is the same as 3 root 5.
Oh yeah,
That's what you're saying.
Yeah.
Don't just forget about that. Just forget, yeah. We're not doing that. You're approximating is good. Okay. So I have some practice problems for you to look at in geometry. Give you a shot. Then on Monday, we'll just revisit these briefly. I'll go through the last section. And then on Tuesday, it'll just be us meeting for kind of go over everything, talk about the final a little bit. And if you want, I'm going to be here. Talk about, I will be here Monday the 2nd. If anybody wants to come in, but it's optional. Monday will finish, Tuesday will finish the final. Monday, December 2nd is actually a hot day. I just had a few people out. It's not actually hot.
We'll have class
What's that?
this upcoming Monday though?
Yeah, next week is the last two. Hey Alejandra, did you lose some papers? You didn't lose any? Oh, okay. What's your last name? Oh, okay, this is different Alejandro now. I just thought this had Alejandro. I didn't actually look at the last.
Yeah, because I was like, lose anything? I don't think so.
Yeah, I couldn't remember your last name. But somebody left something in this room that looks important. Remind me about what?